Good morning, students. Good afternoon, students. Today we'll be going over the quick wins for 26 all the way up to as much as we can get up to. Just a quick reminder that when we go over our quick win questions, the recommendation is to number one, do the problem by yourselves, and then number two, go ahead and check the problem after we do it together. So we're going to go ahead and start where we left off on. Let me go ahead and get my blue ink ready. First question at hand is the graph of the quadratic function is shown, so we know it's a quadratic function. Which values best represent the zeros of the function? So the zeros are your x-intercepts. So we have a 0 here being 3 comma 0. And then we have a 0 here being negative 1 comma 0. So these right here are your zeros. That's all they're asking for. The correct answer here, the zeros of the function. There's two correct answers. The correct answer is negative 1 and positive 3. And those are your two zeros. We go on to number 27. This is a table. It says the linear function. We know it's a linear table. Which function represents the relationship? So all we're going to do, and remember, in order for it to be a function, it can only have one x value right here. If it has two x values, then it is not a function. So I'm going to go ahead and use my table function, and I'm going to go ahead and put negative 4 comma 10 comma 10, negative 2 comma 7, and 6 comma negative 5 in the table. I put the leaf function, I add regression. I know it is a y equals to negative 1.5 x plus 4. And I know my slope or my rate of change is negative 1.5. And I know my last one is a 4. The only one that could be the correct answer is letter A. Now, if I really want to know what negative 3/2 is, all I have to do is come to Desmos and input right here in this function. I put negative 3 divided by 2. And the answer right there will give you negative 1.5. And of course, if I want to see this in a fractional form, all I do is press this button and it changes it to a fraction. Negative 3/2 or negative 1.5. Negative 3/2 or negative 1.5. Once again, the only one that would have been that one would be C. It wouldn't have been C. It wouldn't have been D. It would have been B or A. But again, it has positive 4. So the correct answer is letter A. If we look at the next one says the table shows number of customers at each of the online sales. So what function? We look at the answers and they are all linear. So this most likely is a linear table. All we have to do is submit this one into Desmos and let Desmos do the work for us. So let me go ahead and get my table function. I'm going to put plus sign table. I'm going to go ahead and input all these values into the table. And since it is linear, I'm going to go ahead and cut it down to 3 values because 3 values is more than enough. But again, if you want to input every single one, you're more than welcome to input every single one. I'm just going to input the first 3 values since I know it is a linear table. So the last one was 215. And then I'm going to add regression. And the answer right here, if you look at this answer, it's negative 40.5. And I look at the answers and they kind of put them backwards, but it's negative 40.5. That's negative 40.5x. So then automatically I know this one's wrong and this one is wrong. If I look at the last number right here, it is positive 336. This number's wrong. This number is wrong. So the only answer choice is B. And remember 336.66667. This one is the only one. This one is the only one that could be as close as possible to that. So we have a double check there. So that's the answer for that one. The other thing I want to remind you is that usually our hours are our x value right here. And this time they give it to you. And the f of x is a fancy word of saying, or a fancy letter saying y. If we look at number 29, you can go ahead and do this one. This one is a little tricky, but not really tricky at all. Just make sure we're recording, and we are. So then, looking at this, all you have to understand is that they're only looking for our zeros, and our zeros are our x-intercepts. That is all they're looking for here. So g of x is a fancy word of saying y, or a fancy way of saying y. So I'm just going to get rid of that, and I'm just going to input that into Desmos and let Desmos do the work for us. So then I'm going to input 3x squared minus 2x and minus 5. And then I look at my graph. I look at my 0 right here is 1.667, and I have -1. So -1, I know these two are wrong, so it can only be this one and this one. And how do I get the fraction of 1.667? All I do is input this into Desmos and find out which one matches. 3 divided by 5 is 0.6. That is wrong. And the other one is 5/3. And that is 1.667, which gives us our zeros of, I'm going to double check here, and it is 1.667. So the correct answer choice is letter B. A is wrong because that is 0.67. Remember that they just want the x-intercepts. If we look at number 30, that is also a matching one. And what I would do on this one, it's a linear function, so I know it's going to be linear. Let me erase that. A linear function is our keyword, and they're giving us points. Now, if they don't give you points, it's okay, because you can also get your own points. Right here in red, I'm going to go ahead and put, this is my 0. This is, if I look at it very clearly, it's kind of blurry, but you see that it's 4, 0. Remember, my x, y is in alphabetical order, so that is how I get 4, 0 right here. If I look at my next one, this one is going to be x is 8 and y is -7. If I look at that, sometimes I have to look at that point. And remember that my range and my domain is all real numbers here, because my domain goes on forever and my range goes on forever. But that is not the question at hand. Question at hand is which equation is best suited. So all I have to do is do a table. Once I have 2 points, I know it is linear. So I'm going to go ahead and put the table, and I'm going to go ahead and put the 4, 0, and I'm going to put 8, -7. I'm going to add regression and -1.75 and 7, and automatically by looking at my answer choices, I can get rid of this one and I can get rid of this one. Just by looking at this equation, if I want to look at it very closely, I look at -1.7. I can also input -1.75, and I can put fractional form right here, and it gives me -7/4. And the only one that is correct is letter B. And once again, Desmos did everything for us. So the next one that I'm going to be working on is a causation, association, or both. So this question at hand, and you can go ahead and pause the video and you can try it out and find out which one is the question at hand. Which situation best represents association but not causation? So that means that they're associated with each other, but it is not a cause and effect. If we look at letter A, when the number of spectators at a football game increases, the number of wins for the home team increases. So it doesn't matter whether the football game increases the number of fans. You can have 1 billion fans, they can still lose or they can still win. So this will just be an association. So that is the correct answer choice. But let's look at the other ones. B, when more gallons of water are put into an aquarium right here, the weight of the aquarium increases. Of course, that's going to happen anywhere. If it's in Mexico, it's in Canada, it's in America, it is in Texas, Arizona, McAllen, South Padre Island. So this would be an example of both association and causation. This would be an example of both association and causation, but remember, they're looking for not causation. When the amount of time of an athlete runs increases, the distance she runs increases. So that is an example of both association and causation. This is not correct because they're looking for something that's not causation. This is a cause and effect, and it's an association. This happens anywhere, whether you're in McAllen, Harlingen, Brownsville, or anywhere in the valley. So that is wrong. And when the charge of a cell phone battery increases, the number of minutes of the phone can be used increases. So once again, if you charge your phone, it happens everywhere. You can use your phone longer. So that happens anywhere in America. It happens anywhere in Mexico. It happens anywhere in Canada. It happens in Italy. It happens in France. It happens here. It happens anywhere. McAllen, Edinburgh, Harlingen. So this is both association, causation, not just not causation. So both of these are, all three of these are association and they're causation. Association and causation. So if you want to rate these examples, they're both association, causation, but they are both. So that is the answer choice is letter A. If we want to go to the next one, it tells us a lot of information, and it tells us the florist will be used no more than 8 bouquets of the wedding. Which set, it says, which best represents the domain. And the key word here of domain, and let me go ahead and clear this, page. The keyword here on the domain is not really a keyword, but the keyword is x value. So remember that in between these numbers, we have 1, we have 3, we have 5. So the domain is our x value. So we are looking at domain. So it is 0. We know they're all, right here, we know they're all zeros, but the next one would be 1. The next one would be 2, the next one would be 3, the next one would be 4, the next one would be 5, 6, 7, 8. So the answer choice is G. If we look at the next one, which one makes the equation true? So what we would be doing on this is we would check every single one of these, and whichever one is equal to each other, it's going to be the correct one. So what I would do on this one is draw my railroad track. So I'm going to try to see if this is equal to this. If they are both equal, then it is a true statement. So I'm going to go ahead and check the first one, and I'm just going to input 2 divided by 3. I'm going to go ahead and put my space, or I can put this arrow, and I'm going to go ahead and put open parentheses. I'm going to test out my m. My m here is -9. Do not forget that we're comparing both of them, and we are testing out the m here. So then the first one is -9. And let me erase so you can see the number. There we go. The first one is -9, so I'm going to test out, and I'm just going to input it on decimals. -9 minus 9, close parentheses. And this is the first one. It is -12. On the second column, I'm going to input this one on decimals. So I'm going to go 1 divided by 3, open parentheses. And of course, I didn't skip the space. I'm going to go back. And remember, I have to either click here to get the space, or I can push this arrow. I'm going to open parentheses, and I'm going to go ahead and say, well, what is m? -9. And then I'm going to go -27. And -12 is equal to -12. So that is a correct one. Remember, we're looking for a true statement, and that is true. Now, if you wanted to test every single one of these, you can. You can just replace to make it easier. Instead of inputting, I would replace that and put the next test would be -3. And that gives me a -8. And I would test -3 here. So I would just input 3. And that gives me a -10. So that gives me a false statement. I can go ahead and test the next one. And to make it easier, all I have to do is backspace and put the 1. And then I backspace and put the 1. And automatically I know it's wrong. And then I want to test the last one to make sure, because this is an easy problem to do. And I backspace as I put a 6, and then I put a 6. That gives me -11. Very close, but not close enough. So that is the only true statement, and that is number 33. If you look at number 34, this one is another rate of change. So again, it is linear. It is a Slope, just by looking at this, we know it's a negative slope. Automatically, if we didn't know anything else, we can get rid of A and we can get rid of C. Now we're down to B and D. But again, I want to do 100%. So I go and I input these coordinates. So the X is -3 and the Y is 5. The X and the Y. Then I go here and then I go the X is 9 and the Y is -5. So I have my two coordinates and I can go ahead and put that into a table. So I'm going to go ahead and delete this work and I'm going to input my table format. And I'm going to just input here and here. So I'm going to go ahead and put -3 and 5. And this one is 9 and -5. I go ahead and add the regression. And there it is. My slope right here is -0.83. And then if I want to know what this is, all I have to do is put here under statistics, not under statistics, under equation, transfers this here. And all I have to do is backspace, delete. And then all I have to do is backspace and delete. And I put my fractional model. And it gives me -8/3. But again, this is kind of, gives me too much there. So I'm going to go ahead and just input -6/5. And that's 1.2. That is wrong. And then I'm going to go ahead and input the next one, -5/6. Oops, wrong one. Going a little crazy on the tables. And then I put right here, -5/6. And it's -0.83333, which gives us our slope. And that is the correct answer, letter D. And once again, if they don't give you, let me take the news out. But if they don't give you the points, as long as you get 2 points, that is the correct answer. So we're going to go on to the next one. They're asking for which expression is equivalent to this with X and Y values. So once again, we learned Desmos. We learned how to input this into Desmos. So instead of putting X and Y, I'm just going to put all the X's. So I'm going to put 1/3 6x squared x close parentheses square open 2x cubed x to the 4th close parentheses. So this is a trick that we learned in class that we can get as long as we can get the matching graphs. So I'm going to go ahead, all I did was replace all these with x's. So I'm going to go ahead and put exactly the way it is, 1/3 space, I'm going to open parentheses, and I'm going to just input it the way it is, 6x squared x close parentheses square. So I have this one, 1/3 6x squared x instead of y, and then square. And then I'm going to open parentheses right here, 2x to the cubed. So I put AB here. It's going to be to the cubed, and then x to the 4th. I'm going to put x. Oh, got to go back. And then I got to do my space to come down here. I can't forget my space. So then I'm going to go x to the AB to the 4th. And then if you make a mistake like I did right there, all you have to do is go back, delete, and all you have to do is add in your space right here. Remember, it's telling you right here in not so bold. So then that way it tells you don't forget to close it. Even Desmos tells you don't forget to close it. So then I have my graph here. So what I'm going to do is all these, I'm just going to change them to x's and find out which one is the correct answer. And remember, for it to be equivalent, they have to be the same graph. So I'm going to go ahead and input the first one, x to the AB 7. And then I put my space here, x to the AB 6. And automatically I know that is not the right answer. Why? Because they should be on top of each other. And you can see right here, even if I enlarge it, I can see that there is a space. So that would be a wrong answer. Bad, bad, bad. The next one is, and I want to leave this here. I just want to take off the red. I want to input the next one. And the next one should be the right answer from what I remember in class. AB, that goes to the 7th, and then I go ahead and put my space here. I gotta make sure it comes down, and then I go x to the 6, AB to the 6, and there it is. If you take off the black one, and I put it back on, and I take off the blue one, and I put it back on, that should be the same exact answer, so that is answer choice letter B. So that concludes that part, the part 1 of the 3-day blitz. I'm going to go ahead and move on to part 2 of the blitz. So once again, I have number 36, and this gives you a lot of information, but the important information that we have to know is that it is a quadratic. So what does that mean? We're going to have to input table version of quadratic. So once again, we have to switch everything to make it a quadratic function. So I'm going to use my table, and all I'm going to do is input 1 and negative 2.85. I'm going to go ahead, and when you deal with quadratics, you need to have as many points as you can. When you deal with linear, all you have to have is 2 or 3 solid points, and you are good to have more exact precision. So once again, on the quadratic, I want to input every single one. And then I have 8.5. And then I have negative 7.65. I have 10. And I have negative 5.5. I mean 5.1. And then I have 11.5. And I always want to double check my values to make sure that I put in the right ones, because even one negative will make it go astray. And then I push my regression here. And the only thing I have to remember here, if you remember it's quadratic, I got to change the linear to quadratic here. And the quadratic gives me the equation right here. And if I want to enlarge it, I can see my U shape right there. So I know it is quadratic. It's a big U shape. And then I can enlarge it like that. So automatically, this right here, the equation gives me my quadratic. I push the equation if I want to see it. It gives me y equals to 0.26x. So automatically, by looking at our answer choices, A, F, and G are wrong. Now I have to look at the last one. And then I have negative 3.1. They're both correct. This one's both correct. But then the last one gives us a plus 1. And remember, it is a plus 0. So the answer choice is letter H. That is the correct one. So that is a good way to do quadratics. If we look at number 37 is asking for a linear relationship, so it is another table. So remember, linear relationship, they want the rate of change. Remember, a keyword for rate of change is slope. Remember, keyword for rate of change is slope. So all I do is input this table, and since I know it's linear, I know it's a line, so that means all I need is 2 solid points, but I'm going to input a couple more just to be sure. Whoops, I want to go back. The first one is 0, 460. Sometimes I go crazy and I go and I try to put all the points in one point. But again, always check your work. And I'm going to input only 3 points just to make sure that we know it is a linear and we get as many points. Remember, quadratics, you do need as many points as you can, and exponential, you do need as many points as you can. I'm going to go ahead and put my leaf, and I'm going to get my regression here. If I look at my equation, the number next to the letter is my slope. So I have y equals to 8x plus 460. So once again, my 8 is my slope. So my 8 is my slope. So that is the answer to number 37. These are repeats, so we're going to go on to number 38. And what they're asking for is, they give you numbers and they ask you this time, what represents my range? And remember, my range is my y. This is my y, or I can call it f of x. That's the same thing, fancy word of saying y. So I look at my first one, it's 96. I look at the second one, it's between 96 and 84. So automatically B and C are wrong. And then I look at the second one, and it's between, and I want to erase it a little because I wrote on it. So it is between 84 and 96, and this one automatically is wrong because we're missing a point. This one is correct. The answer choice is letter C. And you got to look at that. Remember that it can't be 96, 84, 72 because there are some points right here, some points right here, some points right here. So you got to make sure those dots match up. So the matchup would be 88, then the next one would be 80. You check the next one and it is 80, and the next one should be 72, and it is 72. So you want to make sure that every single point is on the line. This one is also a repeat. It is rate of change, which you just input the table, and that's it. The next one, number 40, if you look at number 40, and let me check my time to make sure everything's recording. We have a good 30 minutes before I have to conclude the video, so it's 29, 39, 49. Okay, so before 45. So the next one is a slope-intercept form. They're asking for slope-intercept. This is a lot of fractions, but remember, don't get scared because Desmos will do all the work for you. So we got to remember that x and y, it's in alphabetical order. So once again, x is -2 here, and y is actually 6 here. And I look at my next one, and they give me the point of x being 1 and y being -4. So I have my 2 points, and that's all I need. They want me to have the slope-intercept form. So all I do is go into the table right here, and I put my table. And remember that you don't put f of x. You may want to press f of x, but don't press f of x. You want to just put -2, comma 6, and 1, comma -4. And then I'm going to add regression. And here it is. Here's my equation, -3.3333333 minus 0.6667. So again, I want to test one out to see which one is the correct one. So I'm going to go ahead and put that one. And I'm going to go ahead and put -3.33333. And I'm going to go ahead and put that right here, or I can put the fraction, so it's -2/3. I'm going to test out the first one here, and it's -0.6667, but again, this one is close to the x, so that one is wrong, and that one is wrong. If I put the other one, and I'm going to match it up, and it's got to be, this one is -2/3, this one is right, and this one is right. But again, I have two other fractions, so I need for it to be -3.33333. So it's either -11 divided by 3, and that gives me -3.67. So again, -11 would be wrong. And then I'm going to go ahead and put the last one, and it's -10/3. So I'm going to go ahead and input -3 like this, and -3.333, and that is the correct answer. Letter choice D. If I look at my next one, remember that we learned how to do this one. We got to find out which ones are equivalent. Do make sure that you understand. If they ask for not equivalent, they might give you 3 right answers, 1 wrong. So it's a backward, so you got to read it very carefully. So the only thing I do here, and we did it the new method, is we change everything to x's. So we do x to the 9th, x to the 7th, all divided by 4, x to the 3rd, and x to the 14th. So all I'm going to do is change every single thing to x's. So let me get my Desmos and input it the way it gives it. So I'm going to go ahead and input my x value. So I'm just going to do this. I'm going to delete it. And I'm going to go ahead and put 16x to the 9th. And I'm going to do AB to the 9th. And then I'm going to go ahead and put my column. And I'm going to go x to the 7th right here. Go back, and it's AB to the 7th right there. And then I'm going to push my space there, and then I'm going to divide it. And then remember that if it doesn't divide, you can also put parentheses around it. It doesn't hurt you. So I'm going to do 4x to the AB to the 3. And then I'm going to do my space right here, and x to the AB to the 14th. And then once again, I have my graph right here. And I'm looking at my graph, and I'm going to try to find one that is exactly the same as this graph. So I'm going to go ahead and change everything to x's, and I'm going to try my first one. And I'm going to just input 12, x to the AB 6 right here, divided by, and you see how I didn't do the space, so I want to make sure I do my space. 6, and I got to do my space, divided by x to the AB 7th. And you see how it's not even identical, so then this one would be a wrong answer. So then I input the next one. So then I input 4, so I'm going to take off the purple, and I'm going to go ahead and input the next one. So I'm going to go ahead and put 4x to the 6, AB to the 6, and then I got to put my space, and then I got to divide by x to the 7th. And there it is. It is identical. So then once again, I take this one off and I put it back on. It should be identical. Put it on, and they got to be overlapping, and that is your equivalent. Once again, if you want to try C and D, that should be also the correct answer. So the next one, going on to 42. What is the slope of the line? Do not forget, they give you 2 points here. They confuse you with this. You can plot them if you want, but there's no need to plot. Remember, the key word for slope is rate of change, and rate of change is also slope. So all we have to do is put these in a table and find your slope. So I'm going to go ahead and input it into a table, and I'm going to show you an easy way to do this to get your slope. I'm going to do -3, 1. And I'm going to put 5, 8. And I'm going to go ahead and add regression. And here it is. I'm going to add regression. And remember that this right here, the slope, is the letter. It's a number next to the letter. So I can just delete this equation after I get it from the equation editor. And then I'm going to go ahead and add rate of change, which is slope. So that's 7/8. So once again, the correct answer choice is G. And that is rate of change. So that is very, very important. Rate of change is slope. Slope is rate. So if I look at my next one, the next one is, this one's an interesting one. Why is it an interesting one? Because, and let me go ahead and clear my screen. This one is complicated, yet it is easy. They're just asking the quadratic function, and they're giving you the zeros. Our zeros are -3/2 and 5. And remember that Desmos only likes decimals. So once again, I'm going to go ahead and input -3/2 onto Desmos and let Desmos do the work for us. So I'm going to get rid of that, and I'm going to go ahead and put -3/2 divided by is -1.5, and that is the same thing as -1.5, and that's the same thing as -3/2. So the 0 here is -1.5 and 5. So we're going to look for an equation that can be factored form. So once again, we're going to test every single one of these, and whichever one passes through one of my zeros, which is -3/2 or 5, it looks confusing, and you may want to try to put this in, but don't put it in. All you have to do is find out which factor it is. So all I'm going to do is whichever one passes through -1.5 or 5, that is your 0. And you're going to drag and drop. So let's test each one and find out which one is a factor. So then I'm going to go ahead and put, and here I'm going to put x plus 5. And if you want to put parentheses, you can. You don't have to. So I'm going to put x plus 5, close parentheses, and then the 0 here is -5, 0. That is wrong because it has to be 5 or -1.5. So this one would not be a factor. Then I go ahead and put in my next one, and I can leave that one there. I'm going to go ahead and input the next one, and it's going to be x minus 5. Close, and then again, I'm going to go ahead and get rid of this. -1.5, and the factor is 5. So this one is one of our answers. I will drag and drop. Does it matter to which one I drag and drop? No. I can drag and drop this one, or I can drag and drop in this one, as long as you drag and drop to one of them. They're both equal. So I'm going to go ahead and test my next one. So then my next one, does it pass through one of my zeros or negative 1.5 or 5? So then I'm going to open parentheses. I'm going to go ahead and put 2x minus 3, close parentheses. And again, it gives me 1.5, and it is, let me see, 1.5. And I'm looking for negative 1.5, and that one is wrong. So then I'm going to go ahead and take this one out, and I'm going to put in the next one, and I'm going to open parentheses, 2x plus 3, close parentheses, and that is my factor, negative 1.5, and it passes through negative 1.5, so this is my other answer, and I would drag and drop into one of them. I test out this one, and this one probably should be wrong, and that one should be wrong. So that is how easy it is to do that one. So I'm going to go ahead and get rid of it. And I'm going to look at my next one. My next one is the same as this one. So I want to draw your attention to that they are both the same. If you look at that one, if you read that one, the quadratic function, they give you the zeros right here, and they give you the 0 right here. The same thing here. We're looking for a factor right here, and we're looking for the factor of this. So remember, they have to pass through the zeros or the x-intercept. Remember that that is the same thing. So we're looking for a factor that passes through the x-intercept. So I'm going to go ahead and input this equation into Desmos and let Desmos do the work for us. Minus 30. And there it is. There's my U shape. There's my quadratic. I'm going to look at my zeros right there and right there. And if I want to move this so I can see my zeros, and remember they have to pass through the 0 in order for it to be a factor. So I'm going to go ahead and input the first one. And if I want to put parentheses around it, I can. There's nothing wrong with it. But you don't have to, like we did the first one, they have parentheses. This one doesn't even get close to the zeros. Our zeros are right there, our zeros are right there. So again, that one is wrong. So then I'm going to go ahead and take off the blue, and I'm going to input my next one. I know a lot of you want to input, put all of them at the same time and check them at the end. Just don't get confused and make sure you leave the first one there. X minus 10, and it doesn't pass through our 0, so that is wrong. Then I go to my next one, and it is x plus 5. And I left this one here, and it does not pass through my 0. So I'm going to get rid of that one. I'm going to get rid of that one. And I'm going to input the last one, and it is x minus 3. And there it is, x plus 3. It goes directly through my 0, and the answer is letter D. If I look at my next one, number 45, they're saying which function best models the data. So again, they give you a table and they give you a graph. So here is a table, and here is, well, no, this is a graph, and this is a table. So my recommendation, it says it's a linear function, so we know it's a line. The graph might confuse you, so I would recommend to input or use this table onto Desmos and let Desmos do the work. Since we know it is a linear function, all I have to do is input a couple, but I'm going to input like 3 of them. So I'm going to put 0 and 100. Then I want to put in 100, and then 1 and 86. And since this one, you know it's a scatter plot, it goes a little crazy. So I would recommend to input more than just 3. Since it is a regression, a negative regression, it's going down. But I would recommend to, if you can, input every single one of them so we can make sure that it is accurate. But I'm just going to input 4 of them to see if it does come out to the right answer. And I'm going to go ahead and add regression. And I get my equation right there, my negative 14.5x. And I look at my equations. And of course, the closest ones are these and these. These are way off, and these are way off. So then I look at my next one, it's 99.2. And the closest to positive, it wouldn't be this one, it wouldn't be this one. It would be 99.2. This one, the answer choice is letter A. Remember, the best modeling. So the recommendation on this one would probably be to write in every single one. because then it will give you a close regression model. And you see how that changes, and then this gets a little closer and that gets a little closer. So the correct answer is again letter A. If we look at 46, it gives you f of x is equal to x squared, and g of x is equal to, what are you doing to x? You're adding 7.2. What is the vertex of the new graph? So that is what they're asking you. So I would say number 1 is x squared. That is your parent function, and that is number 1. Number 2, what are they doing to the x? What are they doing? Well, they're adding x, and they're adding 7.2. But you got to remember that this is a square, so you got to put the square there. And you just input 1 and you input 2, and we're looking for the vertex of that one. So what I'm going to do is I'm going to get rid of this. And there's other ways to do this if you want. But again, this is my parent function, x squared, and then what they're doing to the x, they're open parentheses. I'm going to put x plus 7.2. Close parentheses, and then I'm doing the square, and this gives me the new one, and I want to get rid of this one because they're asking for the vertex of the new one, and the vertex for the new one is negative 7.2. If I look at the vertex, it's also my x-intercept, so the answer choice is letter B. If I look at 48, once again, this is another one that says what are the factors, but this is a drag and drop. So there's two things you can do. You can do the factoring method, but why do the factoring method if you can let Desmos do the work for you? So once again, I'm going to go ahead and input the 4x squared minus 81. So I'm going to input 4x squared minus 81. And I have my x-intercepts right there. I have an x-intercept of negative 4.5, and I have an x-intercept of 4.5. So whichever one of these it has an x-intercept and crosses through the x-intercept, that is your answer. So I'm going to go ahead and put 9x minus 2. Doesn't even get close. This one is a wrong answer. I'm going to go ahead and put the next one, 2x minus 9. Going to get rid of the green one, and there it is. There's one answer right there, and that is an answer. I'm going to drag and drop it to the correct one. I'm going to get rid of this one, and I leave them there. So if I want to recheck them, I can recheck them. Remember, it has to pass through the x-intercept for x minus 9, and that one doesn't pass. That is a wrong answer. 9x, I'm going to get rid of this, and I'm going to go ahead and put 9x squared, no, 9x plus 2. Doesn't pass through my x-intercept. That is a wrong answer, so most likely the last one is this one. Oh wait, I have another one. So then I'm going to go ahead and try the next one, and I can already tell you that this is the correct answer. Why? Because it passes straight through the x-intercept. As long as it passes through the x-intercept, so I can drag and drop. Doesn't matter the order. You drag and drop, and those are your answers. Another way of doing this is you can also factor this. This is a difference of squares. I can factor it and say, well, what's the square root of this and the square root of that? And then I go plus minus. So I open minus, and then square root of 4x squared is 2x plus 9, and 2x minus 9. And that gives me the correct answer, and that is another way to check the answer to make sure you get the correct answer. If I look at number 48, this is just a matching one, and all I would do is input this into Desmos and let Desmos do the work for us. So I'm going to go ahead and input this into Desmos and let Desmos do the work for us. So then I'm going to input negative 4. And do I have to put in y? No, I don't have to put in y. I'm just going to copy it the way it is. Positive 3, close parentheses, and then I'm going to do minus 2. And I see the graph, and I look at the graph, and automatically by looking at the graph, I know this one is wrong, and, well, no, this one is right. Let me get rid of it. Looking at it, it goes negative, so these are right. And these are going upwards, so this one is wrong because remember it's coming downwards. The other way you can check it is you look at this graph and you find your x-intercept. You find your focal points, and remember to find your x-intercept it has to stick negative 3.5. We look at this one looks good, and then this one negative 3.5. Negative 3.5 is right here. This one is wrong. The correct answer choice is letter H. If you look at number 49, which factors are equivalent? So that means that they are equal. So what I'm going to do is I'm going to input this into Desmos and let Desmos do the work for us. And then I'm going to input every single one of these. Don't worry about these f of x's, and whichever one has a matching graph is your correct answer. So let me go ahead and input these into Desmos and let Desmos do the work for us. So I'm going to go ahead and for open parentheses x minus 3. Close parentheses, quantity square, that is a quantity square, and then I go ahead and put plus 5. Don't forget if it doesn't come out correctly. So this is a minimum. This has no x-intercept, so I gotta look at those qualities for the graph. I wanna get it smaller. I can just click on the screen. I can move this around. I can go ahead and put plus, minus here, and right there. So then I'm going to go ahead and do this one. And I'm going to go ahead and input it in number 2. And it's going to be 16x squared minus 96x plus 149. And automatically I can see that it doesn't even match. This is a wrong answer because they got to be right on top of each other. So that one is wrong. I'm going to go ahead and put the next one for x squared positive 41, and let's see, does this match? It looks like it might even match, so let me just check it. I want to take off the purple. Doesn't match. So you see how my red, take off the purple, it looks like it matches, but once again, where's my graph? Why? Because the graph is up there. It's hiding from us, so you got to be very careful on your dimensions. This one is wrong. So I'm going to go ahead and take off this one. I'm going to put my original function, and I'm going to go ahead and input the third one. 4x squared minus 24x positive 41. And looks like we have a winner. So I want to check it. I want to take out the purple. It should stay the same. And I want to take out the blue, and it should stay the same. That is my answer choice, letter C. And my last one I'm going to do today on this one, and then I'm going to do another video for the rest of the questions, is I'm given a graph, and it gives me a linear, it has a linear relationship. I have my x-intercept, no x-intercepts, but I do have a y-intercept. So I'm looking at my y-intercept, and this y-intercept is a solid point. So my x value is 0 and my y value is 32. Then I want to go and find another point on the graph, so then that way I can put in my table format. And I like this point because it's kind of close, and sometimes it's not going to be kind of close. So then I want to see this one is 40 is my x, and then my y is 104. So then I have 40, 104. So then all of a sudden, hey, I have my table, and I can go ahead and input my table. So then I'm going to go ahead and do that, and I'm going to get rid of all those, and then I'm going to put my table function, and I'm going to input 0, 32, and it looks like an estimate, so let's see what it gives us. And then I have my 40, and I have my 104. Then I'm going to know that it is a linear regression, so I know that it's linear, so it's 1.8x. So they're asking for which situation best represents a situation. So situation with a situation. We have x and we have positive 32, so it's either h or j. This one's wrong, this one's wrong. So now I have to determine which one it is. So what I would do is I would put that in there, and I would get my 1.8. And I'm going to get rid of the front part. I would input 1.8, and I would get my fraction right here. And my fraction is 9/5. The only one that's 9/5 is letter J. That is wrong. So if I look at my 51, because I know 51 is easy, and I can do that one. 51 is f What is a function when f is 4? All I have to know is x equals to 4. That's all I have to know, x equals to 4. And all I'm going to do is input 4 in place of this, and I'm going to go ahead and let Desmos do the work for us. So I'm going to go ahead and put 3 times x to the 4th square, so I'm going to put 4 square, minus 7. And Desmos did the work for us, and that is 41, letter C. If I look at 52, that is going to be a matching one, so I'm going to go ahead and let you do that one. 53, that's another easy one, so I'm going to let you do that one. And that concludes our video. The next video will have 52 and 53 worked out for you. So once again, my recommendation is to look at the problem, work the problem before, and then do the work, and then see if you get the right problem. So at this time, it concludes our 26 through 51. And once again, have an amazing day. You are amazing math students, and I know you're going to do amazing on the test. Keep up the great work, and we'll see you in class. Thank you. If you have any questions, don't hesitate to reach out anytime.